All right, we have a pretty easy looking integral here today from Caltech 2024. This was number 13. And even though it does seem pretty easy, there are a couple interesting points. Now, first of all, you could consider a u substitution right here to clean it up. I'm gonna skip it just because it doesn't really do much for us. You can do it fine without it. So I'm just gonna skip that u sub, but I will use the identity. If we have tan squared or something, we have the identity that if we have tan squared x plus 1, this is the same thing as secant squared x. So what it's going to allow me to do is rewrite the integral, putting it in terms of secant squared, because we know how to integrate that one. So we'll do secant squared, same input, and then we're subtracting 1 on both sides here, so we'll have minus 1 dx. Go ahead and integrate. Integral of secant squared is going to be just tangent. So we end up with tan 2x minus 1. So here it's kind of like doing the u sub in your head. We just need to remember that 2 right there. So we divide off the 2, and then here this is going to be minus x evaluated from 0 to pi over 4. Plug in pi over 4. What we're going to have here, let's see, it's all over 2. So we're going to end up with tan. This is going to become pi over 2 minus 1. Then for this part, we get a minus pi over 4, plug a 0 in, that gets zeroed out. Over here, we end up with minus tangent. That's going to get zeroed out, so we end up with minus 1 over here to over 2. Now, I don't see why you couldn't just leave this as the answer. It seems totally valid. I think they would accept this. I don't know how far they expect you to simplify it. I'm going to simplify it just because it's going to look nicer and it's going to be more interesting, because this is, if you could just stop here, it's very easy. But the first thing we want to do, I want to clean up this. Tangent's an odd function. So for an odd function, I can take the minus sign out front and just cancel it with this. So we can turn this into a plus, get rid of the minus here. And then here, I want to use an identity on this. You could just use the tangent angle difference identity. The only reason I don't is because you'll end up with tan pi over 2, which is going to infinity. I don't want to confuse it that way, even though you could. But I'll break it up into sines and cosines. So we'll do it like this, turning tangent into sine over cosine. And then we'll use angle difference on these each separately. So we end up with sine pi over 2 times cosine 1. Same sign, so it's going to be minus, and then flip them. So we end up with cosine pi over 2 sine of 1. And then we do the same kind of thing, the identity on cosine. But then in this case, it's just a different pattern. So we end up with cosine here. This becomes a plus, and then we end up with sines over here. But now cosine pi over 2, that's just 0. So this term goes away, but then this term goes away. We end up with, I could clean it up first, but we end up with this fraction, this piece over this. But then we can just cancel the signs, or it's 1 anyway, so those would just go away. And what we end up with is cosine 1 over sine of 1. Of course, that's cotangent of 1. I'm not going to simplify it because I'm going to want to combine it with this right here. So let me take this and put it back in this expression. Okay, now let me just explain what I did so we keep it all clear. The thing we found before, cosine 1 over sine of 1, we have that right here. But I'm combining this with this, putting it all over the common denominator of 2. And then I took tan of 1 and I wrote it back as sines and cosines, because I want to really, what I want to focus on is just simplifying this part right here before we finish. And then we just, of course, brought down the minus pi over 4. So now that we have this, let me erase the board and we'll just focus on simplifying this, and then we'll finish it off. Okay, now to make it more general, I just put it back to x. Doesn't matter because everything's the same. We have the angle 1. So I just want to do a general case on this for combining these. Then from here, we'll get a common denominator of, here we need to multiply in sine. Here we need to multiply in cosine, but we're doing it multiplying by 1. So let's do it like this. And then when you put this together, the common denominator is just going to be cosine times sine. Multiply that out, you have cosine squared x plus sine squared x. But now this thing right here, that's just a 1. That's not a very good one, but that's a 1. So this here, that goes away. And then this here, we can write it like the double angle formula for sine. If I multiply in 2, and then so I'm not changing it, we divide off 2, then this stuff in the numerator here is going to be sine 2x. So clean that up, flip the 2 up top, and we end up with 2 over sine 2x, which is also the same thing as 2 cosecant 2x. And I think that's going to be a nice way to simplify this right here. So we'll put it back, but remember, we're doing x equals 1. So what we end up with here is 2 cosecant 2 times 1, so the angle now is 2 over 2 minus pi over 4. 2's are going to cancel, and for my final solution on it, we just get cosecant 2 minus pi over 4, and that's it. All right, so there you go. Like I was saying, on an integration bee, you kind of want the fastest answer, so you wouldn't really bother simplifying, I don't think, because then you could probably do it much faster, but I think the simplification was nice. And this also matches what they have in the answer key, so I usually like to do that if I can. Try to get a cleaner solution that looks like what they got. So anyway, that's it for today. Thanks everyone for watching. Have a good day.